Hello everyone, I'm Kaushik. Today I'll be covering the different ways that we can monitor the DAOS usage on Aurora. Uh, the first one is the DAOS interception library. So as Mohammed mentioned before, enabling just this one environment variable DIL report equal to one, you will be able to get the monitoring from the interception library. So if you have 24 ranks, you will have 24 set of this outputs. So um, so you still need the libpal for DFS interception library and just this environment variable. For this entire presentation, I'll be using this IOR configuration. So basically, it's just two nodes with 12 ranks per node. And the transfer size is 1 MB, and the block size is 10 MB. So that's like 24 ranks writing 10 MB. The total file size will be 240 MB, and it's a single shared file independent. And I'm writing to this temp, pool name, container name, and the file. So this is the POSIX DAOS interface. So for the rest of the presentation, I'll continue to use this consistent configuration. So this is the first monitoring with the DAOS interception library. This is one way everything is going as expected through the interception library. The second one is to enable the DAOS client-side logs. So you just set this D log file and the mask like one or info or error, uh, whatever kind of logging that you want. And you can also append a PID so that the file looks nice with all the process IDs. So this is from the DAOS client side, the ECB's compute node side log. So you can see all the different information that gets passed to the DAOS clients. For example, using efficient binding across all the 8 NICs is very important for performance. So you can verify all those details here. So this is with monitoring with the DAOS client-side logs, and here I'm just quickly showing that we can also monitor we can also get the server-side logs based on the demand, but this is just a quick peek. So if you have 128 DAOS servers, so each server will have a admin log, control log, and each engine will have the set of logs. So this is from the client side, this is from the server side, and so you can, based on that time of activity, you can collect some logs. So this will be very helpful in terms when you have any errors below the Mercury layer thing. So next, I'll be spending most of the time with Darshan. So most of you would have been already using Darshan instrumentation for POSIX with Lustre. So Darshan is a scalable HPC IO characterization tool which can accurately picture the application's IO behavior on complex HPC applications. So you can get all the access patterns, investigate, tune the IO behavior, and the overhead is very minimum. It's from the lightweight design of Darshan, and it can help uncover critical insights when you're using DAOS. So the basic concept is very simple. So you just preload the Darshan library when you're running MPI exec, and it'll generate a binary file, and you can use Darshan utilities and tools on this binary file to get all sorts of analysis from it. So this is from Argon developed tool from Shane. So he did the most of this work. Um, so the first, you have multiple options for accessing DAOS storage, and you have different performance with different interfaces. So if you're just going to use the diffuse interface without any interception library, there won't be any modification required, but still it'll go through one neck, and Darshan would give you just the POSIX level instrumentation, and you won't have any insights into the DAOS level. So the second option is with interception library. So yeah, in this mode, you still don't need any app modifications, and and the performance is now improved because both the data and metadata goes to the interception library, and Darshan supports all POSIX, DFS, DAOS level instrumentations. So the third level of monitoring is when you're using the advanced level of APIs, when you're using libdfs or libdeos, Darshan can give you the full instrumentation, but however, this requires a little modification. Of course, we'll be using the Deos APIs here. So uh, so on Aurora, if you want to install your own setup of Darshan profiler on Aurora, you just need to load Deos, clone the Darshan repository, and if you are going to use along with HDFI or Peanut CDF, you need to pass those arguments as well. And it is important to run this Perl script, which will create the directory in this format with year, month, and day, and you can collect your logs when it's done from this location, or you can also pass the Darshan log file location. This is just for future reference. And once the Darshan binary file is ready, now you can use the PyDarshan module to get all the cool UI with all sort of analytics there. So this is a bit tricky when you're installing with the new M1 Mac laptops. So the first thing is you need to have your own Conda, activate your environment, and you need to get this libdarshan utility library first, and then install the PyDarshan module. So Shane also released the pip install PyDarshan. You can do that directly as well, but just make sure you enable this DYLD fallback library path when you're running it on a Mac. So this is also just for future reference. So this is how I collect the Darshan analysis. On Aurora, we have this on the image. So you just use this module use location, module Darshan, and this order needs to be maintained. You first enable the lib Darshan library, and then the libpal. If you are facing any issues, you can reverse this one, swap this one by having first the libpal and then the libdarshan. But if you're also going to use Peanut CDF and HDFI, you also need to have this in your LD preload. And if you are using the GPU tile compact.sh script, then you will have to make a copy of that and add your LD preload there in order to get the Darshan files. So yes, I'll be still using the same config that I mentioned before, 2 nodes, 12 ranks each, transfer size of 1 MB, block size 10, total files is 240, single shard file independent, writing to the POSIX, temp, pool name, container name, and file name. So the first step, once you have that LD preload and then the MPI exec, you will get this .darshan file, which will be in the year, month, day location, or wherever you pass it. So now the first utility is the Darshan parser. You can just point to the Darshan parser and point to this file. You will get this text monitoring logs. You can also see that, so there are 24 ranks, each writing uh, 1 MB transfer. So you would see that 240 reads and writes here. So this is also one way to collect all your logging with Darshan parser. So the next one is with the PyDarshan. So as I mentioned before, so let me go back to this one. Yeah, here. So you just have to LD preload to the Darshan util. It's not needed. It's already in the LD library path. You can just add Python -m Darshan summary and point to the .darshan file, and you will have a HTML file which reports all the plots. So the first thing is you can look at you can see the cross module comparison about how much it's an average across all the ranks where the amount of runtime that each process spent per performing IO. So the POSIX, STDIO, and DFS, the total runtime spent here. And the second one is the heat maps. This is very helpful when so you can see there's three different heat maps for POSIX, STDIO, and DFS, and this is based on time and the number of ranks. So the top bar shows the aggregate IO volume over time. So for example, most of the IO happened at this time here with POSIX, and on the right bar is the IO distribution across each rank. So like you can see that all 24 ranks did IO equally. So this stdio is just the print statement that I have with IO usually prints something like this. So initially it printed out this one, and then it printed out the summary results here. Uh, yeah. So that's these two areas. So and the last one is with the DFS, the same principle as before. And you also get per module statistics on the total file size, bytes read, and all that information on three different IO interfaces. And the operation counts as well. So you can see here that at the POSIX level, there are like 24 ranks time 10 megabyte blocks that gets transferred here to the DFS level. And I think each rank opened twice. Um, so you can also get the operation level statistics and and the access sizes as well. So as you know that we are using 1 megabyte transfers with 10 megabyte blocks. So all that falls under this one, this region here for both reads and writes. But at DFS, we just noticed this one that we still have the 240 accesses on both reads and writes, but we just found that there is something more happening at the DAOS level where there is this 48 final reads were of different sizes. So we are still investigating into this one. Um, but the thing is, for your application, you will be able to get and monitor all these different profiling. And this is with POSIX. You also get the access patterns. So since here it's a single shared file, all ranks are writing at different time periods. So you can see that at least 216 of those were consecutive, like one after the other, and others happened at a different size time. So the access size and counts and this one is the DFS at /temp and stdio. So this covers everything with the darshan monitoring. Um, so basically, you will have a HTML report like this. This one is with Luster. You can see the heat map, stdio, cross-module comparisons, operation counts, and POSIX, stdio, and so on. And this one is with the DFS on this location here, whereas this one is with on the Luster location here. So here you'll see the same things that I explained before: POSIX level statistics, stdio level statistics, and DFS level statistics. So that covers the end of my presentation.